All right, here we go. We're going to be doing something a little bit different. Normally, these ideas, critical values of f, where f is increasing, where f is decreasing, and local extreme values of f, aren't terribly hard for us because we know critical values of f are where the first derivative of f is equal to 0 and defined. F is increasing where f prime is positive. F is decreasing where f prime is negative. F has a local minimum where f is continuous and f prime changes from negative to positive. F has a local maximum where f is continuous and f prime changes from positive to negative. And we're good at that using equations. We might even be really good at that using a graph of f. This is not a graph of f. We're given a graph of f prime. So the ideas are the same. We're just going to find that information in a different way. So a critical value of f is where f prime is equal to 0 or undefined. So we look at the graph of f prime and figure out where that graph is equal to 0, where this graph is undefined. F prime is equal to 0 at x equals 0 and at x equals 1. It doesn't appear that f prime is ever undefined. So where is f increasing? You might think over here and over here, but remember we're looking at a graph of f prime. F prime is increasing when f prime is greater than 0. Well, this is a graph of f prime. Where is this graph greater than 0? Well, f prime is greater than 0 from 0 to 1. Also from 1 up to infinity. Now that's a little bit weird. Just break it down. Pretend like you don't have this graph. Where is f increasing? When f prime is positive. This is a graph of f prime. Where is this graph positive? Wherever this graph is above the x-axis. So let's see if you can get where f is decreasing on your own. Do you have the idea? F is decreasing when the first derivative of f prime, is negative. So f must be decreasing from negative infinity up to 0. Because f prime, this graph, is below the x-axis, that means f prime is negative from negative infinity to 0. Where does f have a local minimum? Let's see. X has a local minimum when f is continuous, and f prime, let's see if we can write f prime, changes from negative to positive. Where does f prime change from negative to positive? Right here at x equals 0. F prime was negative to the left of 0 and f prime was positive to the right at 0. So that's f has a local minimum. F prime changes from negative to positive at x equals 0. So f has a local minimum. At x equals 0. Do you have to worry about continuity? We'll get to this soon, but you don't. If the derivative of a function exists at a point, that means the function must be continuous at that point. We'll get to that next time. Let's look down here. Where does f have a local maximum? F has a local maximum when f prime changes from positive to negative. Look at the graph. Where does that happen? Yeah, it does not happen. This graph f prime never goes from positive to negative. This graph doesn't go from above the x-axis to below, so f has no local maximums. I hope that helps.